All right, let's break down linear regression. It's a key tool for finding patterns in your data.
So, let's say you have a bunch of data points like this. How do you find the trend? This is a classic supervised learning problem. We're teaching a machine to make predictions based on examples.
And our tool for the job is linear regression. It's all about finding the best straight line.
But what does the best line actually mean? How do we even measure that?
We do it with something called a loss function. It basically just measures how wrong our model is. See that vertical distance from the line to each point? That's the error, or residual. Our goal is to make the total squared error as small as possible. Big mistakes get penalized more. Think of it like this. All possible lines create an error surface. We just want to find the bottom. We find that lowest point using calculus or by using an algorithm to walk down to the bottom.
Okay, but what happens when the data isn't a straight line? That's pretty common, right?
Well, we use a clever trick called feature mapping. We basically create new, smarter input features.
By adding features like x squared or x cubed, we can literally make our straight line bend and curve.
This new power is awesome, but it comes with a huge risk, something called overfitting.
Check this out. A simple curve gets the general trend. A complex one hits every single dot.
Yeah, it's like a student who just memorizes test answers but doesn't actually get the material.
And here's the proof. The overfit model completely fails when you give it new, unseen data. And look at the model's weights. They get ridiculously huge. That's a classic sign it's just chasing noise.
So how do we stop our models from going wild like this? The answer is regularization.
Regularization is basically a penalty for complexity. It encourages the model to find simpler solutions that work better.
Common types, like L1 and L2, put a leash on the model's weights to keep them small.
So it's all about a trade-off, fitting the data well, but also keeping the model simple.
And this leads to a core idea in machine learning. It's all about mixing and matching these pieces.
This idea of penalizing complexity is huge. So what other real-world problems could this help solve?